In section 12.4, we're going to simplify rational expressions. So let's start with a little bit of terminology. For example, what is a rational expression? Well, this is an expression that can be written as a ratio, which in other words is division, of two polynomials, and we have to follow this requirement that the denominator cannot be zero because we cannot divide by zero. An undefined rational expression will be a rational expression that has a denominator of zero. Remember, we don't want that. And then we want to look at excluded values. An excluded value is any value that causes a rational expression to be undefined. Again, we want to avoid that. So the key here to simplifying rational expressions is to look for common factors between the numerator and denominator, which will allow us to cancel. So here we have a times c in the numerator, b times c in the denominator. That means we can cancel these c's. Remember that we can only cancel factors, what's being multiplied in the numerator or denominator, and then this will simplify to a over b. So here's an example where we have x plus 3 times x minus 2 over 7 times x minus 2. We have this common factor here of x minus 2, and so we can cancel that binomial x minus 2 in both numerator and denominator, and we end up with a simpler expression here of x plus 3 over 7. So let's look at some examples, and for starters we're going to look at the idea of excluded values. So find the excluded values, if any, of the expression. So what we're looking for is we do not want that denominator to be 0. So in other words, you could say that we want x minus 2 not equal to 0, and if we were to add 2, and normally of course you would see this written x minus 2 equals 0, so here we want x not equal to 2, so our excluded value is 2. Okay, so here let me write this as what would lead us to 0. So look at the denominator, and here we have a product. If either one of these is 0, we get a denominator of 0. So we don't want x plus 1 equal to 0 or x minus 8 equal to 0. And of course we subtract 1 to get x equals negative 1, add 8 to get x equals 8, so the excluded values are negative 1 and 8. We cannot allow x to be negative 1 or 8. Here we have x minus 5 over x squared, oops, that's a squared, minus 12x plus 32. Okay, so now what we need to do is try and factor that denominator if we can. So this is equal to x minus 5 over, and this does indeed factor, it factors to x minus 4 times x minus 8. And that means we cannot have x minus 4 equal to 0 or x minus 8 equal to 0. So x cannot be 4 and x cannot be 8. So our excluded values here are 4 and 8. Here we have x plus 3 over x squared plus 4x plus 5. And it turns out if you try to factor this, this is not going to factor. If you tried the quadratic equation, you would find no solution. If you were to graph this, you would see something like this, roughly speaking. In other words, that function has no 0, which means we have no excluded values. Okay, so x can be anything here in terms of avoiding a denominator of 0. Alright, next set of examples. Simplify the expression. So here we want to factor out whatever we can from the numerator, whatever we can from the denominator, and then see if we can cancel. So this is equal to 3m over, and from 12m and 18 we can factor out 6. That would be our greatest common factor. So we have 6 times 2m minus 3. And then we look and we see, well, 3 goes into 6. So 3 goes into 3 once, 3 goes into 6 twice. So we end up with 1m, or simply m, over 2 parentheses 2m minus 3. And that would be our answer right there. Okay, number 6, we have 4x over 8x squared plus 2x. So we can't factor anything out of the numerator because that's just a monomial, but we can factor 2x out of the denominator. So we have 4x over 2x times, and then that will leave us with 4x plus 1 in parentheses. And now we have a factor of 2x, a factor of 4x. The x's will cancel, and then 2 goes into 2 once, 2 goes into 4 twice. So we're left with 2 in our numerator, and then 1 times, so we can just write 4x plus 1. Okay, number 7, here we have k plus 3 times k minus 1 all over k minus 9 times k plus 3. So notice that we have a common factor in the numerator and the denominator. So remember, we're not just canceling k, we're not just canceling the 3, we're canceling that entire factor of k plus 3, so that we're left with k minus 1 over k minus 9. In number 8, here we have t squared plus 3t over t squared minus 9. So we have a binomial in both numerator and denominator, and so we look to see if we can factor. In the numerator, we can factor out a t. This is equal to t times t plus 3. And in the denominator, you hopefully recognize this is a difference of 2 squares. And so this is t plus 3 times t minus 3. So we cancel our t plus 3, and we're left with t over t minus 3. And notice now with this nice simplified form, we only have t to the first power, which is usually a lot easier to calculate than dealing with t squared. Number 9, here we have q plus 4 quantity squared over q squared minus 16. Okay, so then we look and we wonder, this I'll just leave the way it is, q plus 4 squared. But again, we have a difference of 2 squares, so we can factor this denominator into q plus 4, q minus 4. Now, the q plus 4 in the denominator will cancel one of the two q plus 4's in the numerator. We still have one q plus 4, so that will remain in our numerator, over q minus 4. And we're done with that one. And number 10, here we have x squared plus 7x plus 10 over x squared plus 2x minus 15. So we have a trinomial in both numerator and denominator, and we look and we see if we can factor. If you want to set up your x, you can do that. You might be able to do this by visual inspection at this point. This is going to factor into x plus 2 times x plus 5 in the numerator. And if you want to set up your x, you can confirm that. Or multiply this back out, and you'll get x squared plus 7x plus 10. And this is going to factor into x plus 5 times x minus 3. And notice we have an x plus 5 factor in both the numerator and denominator. That means we can cancel x plus 5, cancel x plus 5, and we're left with x plus 2 over x minus 3. Okay, so there you go with simplifying rational expressions. And notice that one of the keys here is remembering to factor, look for common factors, and look for opportunities to cancel. Good luck.